Alright, this is FRQ video number 1. So as you can see, a person throws a ball from a tower. That is our scenario. Then either the height of the tower, I will say, would be 856 feet, and the ball is being thrown at 88 meters per second at an angle of 45 degrees down. And then we're not going to consider wind resistance. Okay, so what time will the ball reach the highest point? So, um, first we need to find out what angle is it being thrown at. It's being thrown at 45 degrees angle, a 45-degree angle, but it's not being thrown upwards. It's being instead being thrown downwards. This changes things because if it was being thrown upwards, let's say this is the where the ball is being thrown from. If it's being thrown upwards, then the highest point would be sometime after it's thrown. However, since it's being thrown downwards, the highest point is already it'll just travel downwards. So the highest point's already at 0 seconds. So this was a trick question for students that were not paying attention to the scenario because it's being thrown downwards. Not usually a question would ask if it was being thrown upwards, which would change things. But since it was being thrown downwards, the highest point is at 0 seconds. So B, how long will it take for the ball to reach the ground from the top of the tower? So first, what is it asking? B is asking how what is the time it would take for the ball to hit the ground? So if we can think back and we can use the formula we know, which is delta y is equal to 1/2 at squared in the y direction plus vi in the y direction t. So this equation, we have all variable. We're solving for t, so we have t in this equation, and then we know delta y, we know acceleration in the y direction, and then we could figure out the initial velocity in the y direction. So for initial velocity in the y direction, we, um, we know that we can take the velocity 8, the total velocity 8, and then we can do sine in the angle of 45. And this will give us the velocity in the y direction, which will be 5.65. Oh, excuse me, 5.657. There we go. I'll round this to 5.656 or 5.66. All right, and then now we have everything we need to solve. So delta y, which is 856, is equal to 1/2 a, and acceleration in the y direction is just 9.8. But we gotta remember to put the negative since it's accelerating downwards. And then plus VIY, which we just figured out is 5.66. But again, we remember to put the negative since the initial velocity, y, it wasn't being shot upward. If it was being shot upward, it'd be a positive 5.66. But since it was being shot downward, then it has to be negative. So 5.6. And so it's already moving it down. T. And then now we can use quadratic. So we set this side equal 0, equal to 1/2 times negative 9.8 is negative 4.9 plus excuse me, minus 5.66. And then if we subtract 856 to the other side, it'll just be minus 856. We plug this into our quadratic equation, and we will end up with, okay, we get 13.2046 seconds as the time it would take to reach the ground. Oh, yeah, I forgot to put t squared here. My bad. T squared here, and this right here will be a t with time for time, which will be solving for time. All right, how far will the ball land from the tower? So now that we have the amount of time it's in the air from part B, 13.2046 seconds, we can find out what was it traveling in the x direction, since the x direction is the only, velocity that will matter for how far it will travel from the tower. So instead of using 8 sine 45 for the y direction, we can use 8 cosine 45. And we end up with the same number because it's at a 45-degree angle. So 8 is equal to 5.6568, large down to 5.66. And now that we know the time, all we need to do is plug in the displacement again. So delta x, which is what we're solving for now, is equal to 1/2 at squared plus vix_t. So first, there is no acceleration in the x direction, since there's only initial velocity. There's no acceleration, so we can just cross this out. We're left with vix_t. Vix we just found was 5.66, and time we found earlier 13.204. And you solve, you're equal to 74.693. 74.693 meters. Away from the tower in the x direction. Okay, write down that a little nicer down here. 74.93 meters. How far? What will the final velocity of the ball be? Okay. So the ball, first we have to split it up into two velocity components, the x component and the y component. We know from part B and C, we know from part C that the velocity in the y direction, the x direction, excuse me, the velocity in vix does not change since there's no acceleration, so it'll stay 5.66 even at the end. So vix 5.66 via fx is equal to 5.66. However, there is acceleration in the y direction, 9.8. Therefore, VIY, the velocity in the y direction will not stay the same. And so how can we figure out velocity in the y direction? We use our formula, VF squared minus VI squared is equal to 2A to A1 in the y direction. So first, VF squared is what we're trying to figure out. Minus VI squared. We know from the previous part that VI squared is 5.66. Well, it's negative 5.66. Is equal to 2. Acceleration is negative 9.8. Delta y is 856. Parentheses outside. So, give me a second. I need a bit more space. Okay, I'm just gonna move my work over to this other tab over here, since I don't have any more space. So now that we have the equation VF squared minus, so it's negative 5.66 squared, but a negative squared is just, it'll become a positive. So negative 5.66 squared is equal to 32.056. And then is equal to 2A is just 2 2 times negative 9.8, which is 19.6. Okay, delta y, which will be 56. So now we just solve. So negative 19.6 times 856 is equal to negative 16,777.6. We divide this over. We get 523.727 equals to VF squared, and we square root. So VF is equal to VF is equal to 22.88. But remember, since it's moving downwards, it's a negative, so negative 22.88. Let me add it here. Let me create a section here. The final velocity of the ball will be 22.885 negative 22.885 meters. Oh, I'm so sorry. I forgot one last step. Remember, this is VIY only. This is VY, excuse me. VFY in the Y. It's only velocity in the Y direction. Now we have to combine the X direction and the Y direction, and we know how to do that using Pythagorean theorem. So a squared plus b squared is equal to c squared. So a squared? We'll just say a squared is our x, 5.66 squared plus b squared, which will be our VFY. Say negative 22.88. And then c squared is our velocity, the x component and the y component together. So 5.66 squared is equal to 32.056 plus negative 22.88 squared is equal to 523 equal to c squared. We add those two. It's equal to 555.762 c squared. Square root. We get 23.574. But remember, again, it's in a downward direction, therefore it's negative 23.574 meters per second is equal to the V final. Okay, how much time will the ball be in contact with the backboard of the hoop? Okay, this question is asking When the oh, so excuse me, I need to show the video again. When the ball hits that backboard right there, how much um how much time will it be in contact with that? So we can use an equation we know as Ft, force time, is equal to mv. Okay, so as you saw in the video earlier, ball, then it stops. It hits the backboard and the ball stops for a moment. Okay, how much time will the ball be in contact with the backboard of the hoop? So Ft, F, force change of time is equal to mass change in velocity. So um so what we're trying to figure out is the time it was in contact with the backboard for. So first mass. Oh, excuse me, I never gave the mass for the ball. Since we never used. So the mass of the ball, will be 1.3 kilograms of the ball. So now we know the mass of the ball is 1.3 kilograms and the change of velocity. As we see in the video, the ball hits the backboard, then it stops. Or yeah, for that moment, it stops. The split second, it stops moving. So that's the scenario we're gonna use. So the ball stops, it hits the backboard, stops for that split second. That's the scenario we're gonna use. It's gonna stop. So the change of velocity, it goes from negative 23.574 to 0. So the change of velocity is 23.574 is equal to force. And how do we calculate force? Force is equal to mass times acceleration. 1.3 is the mass, and the acceleration uh, you can figure out the acceleration of the ball is 9.8. So times 9.8. The force is equal to 12.74. So now that we know the force is equal to 12.74, now all we have left is time. And so now we can just solve. So 1.3 times 23.574 is equal to 30.647. And then we can divide 30.647. Excuse me, let me erase this. Divided by 0.7, 12.74 is equal to 2.4055. Then the time we just bring down. So the time that the ball's in contact with the backboard is equal to 2.4055 seconds.